So higher order non-homogeneous equations. Solving. So we will describe the method of solving non-homogeneous differential equations. But before we do that, remember that an equation of the form an of x is called a non-homogeneous equation when g of x is non-zero. So if an of x, an minus 1 of x, all the way up to a naught of x are taken as constants, then let me call this one. One is said to be an unhomogeneous equation with constant coefficients. So, and note that G is non-zero. So our interest would be to solve equations which takes that structure, that the right-hand side of this differential equation is non-zero, and the coefficients of the functions involving y and its derivatives are purely constant numbers. This is where the coefficients of the y functions and their derivatives are functions of x in the general form will be done in another course. But here we start, our interest is only to solve equations when the coefficients are purely numbers or real numbers. So let's define particular solution to such an equation. So a specific solution yp of x that has no arbitrary constants and satisfies equation 1 is called a particular solution. So there's a function yp which will satisfy the equation 1 and which is also missing arbitrary constants, then such a function is called a particular solution to that given differential equation. So the general solution, the solution to the homogeneous part of equation 1 has to mean the solution to this equation an plus an minus 1 plus other terms plus a1 y prime plus a naught y equals to 0. So homogeneous simply means that now you fix the g part to be 0. It's called a homogeneous solution written as YH, or sometimes we write it YC to mean complementary solution. So the general solution to the non-homogeneous solution, non-homogeneous equation ANYN plus AN minus 1 YN minus 1 plus AN minus 2 YN minus 2 plus A2 Y double prime plus A1 Y prime is given as y of x is yc plus yp. That simply means you take the complementary solution of the homogeneous solution and then add to the particular solution of the differential equation. Remember, the homogeneous solution or complementary solution have the same meaning. What you get after equating the right-hand side of the non-homogeneous equation to 0. So the interest here will be, how do we find the particular solution to a given differential equation? And now with the particular solution, we get the homogeneous solution, and then the final general solution will be the summation of the two types of solutions. So to solve the non-homogeneous equations, we will use one method of undetermined coefficients, and two method of variation of parameters. So these are the main two methods that we are going to discuss: method of undetermined coefficients and method of variation of parameters. It is advisable to know the nitty-gritties of each of these two methods, when and how to apply them. So before we narrow down to each of them, let's verify that yp of x given by 3/5 sine x is a particular solution of the differential equation y double prime minus 4y equals to minus 3 sine x. So that simply means, check that when you get the second derivative of the function yp, you subtract 4 times the yp itself, you should get minus 3 sine x. So yp is given by 3/5 sine x, which implies yp prime will be given by correct 3/5 cosine of x, which means second derivative of yp minus 3/5 sine x, correct. So the claim that yp is a solution means that if I replace yp for y, then this equation must be satisfied. So yp double prime minus 4 yp would give us minus 3/5 sine of x minus 4 times yp is 3/5 sine of x. So which will be minus 3/5 sine x minus 12/5 sine of x. So what do we get by adding minus 12/5 to minus 3/5? So negative 15/5, which is simply negative 3 sine x. So which is satisfying the condition, which is satisfying the right-hand side of the given differential equation. So therefore, since yp equals to positive 3/5 sine x satisfies the given differential equation, then it is a particular solution. Particular solution because it is satisfying the differential equation, and at the same time, the function doesn't have an arbitrary constant. So what happens in the method of undetermined coefficients is to find this particular solution to a particular homogeneous or to a particular non-homogeneous differential equation. And then once we have the particular solution, we add to the homogeneous solution to get the general solution of the whole non-homogeneous equation. So we will describe how the method works by first stating the condition when it can be applied, depending on the structure of the g function. And then once we have illustrated the steps, we'll do an example to illustrate how we apply the method to solve particular cases. So steps. Okay, so the first method, undetermined coefficients. So steps to follow. Steps on how to solve. The equation an y power n of x plus an minus 1 y power n minus 1 of x plus a1 of x, a1 y prime of x plus a0 y of x equals to g of x. So remember, in all these cases, g of x is a non-zero function. So even before we give the steps, it should be very clear from the start that the steps we are going to describe only works when G is a linear combination of these functions. So method works only when G of X is a linear combination of the functions so the first function, we may have polynomials 1x, x squared, x power 3, etc. We may have e power kx. We may have x e raised power kx. We may have x squared e raised power kx. We may have x cubed e raised power kx, etc. We may also have e raised power alpha x times cosine of beta x. We may have t e raised power alpha x cosine of beta x. We may have t squared e raised, okay, so this is not, this is x, not t. X squared e raised power alpha x cosine of beta x, etc. Or we may have e raised power alpha x sine of beta x, x e raised power alpha x sine of beta x, or x squared e raised power alpha x sine of beta x, etc. In simple terms, the structure of the G function should either be involving a polynomial or an exponential function, or a function that involves cosine, or a function that involves sine, or product of the terms in a polynomial and trigonometric with respect to cosine and sine, or product of the polynomial terms with the exponential function. If g of x doesn't have any of this structure given in this list, then we do not use method of undetermined coefficients. So that should be clear from the start. You need to see a sine, you need to see a cosine, you need to see either an exponential or a polynomial expression for g. Assuming that is the case, then these are the 4 steps we have to follow. Step number 1. Solve the corresponding homogeneous equation to get YH solution. And how do you do this? You simply fix G to 0 and then solve the resulting equation by the previous steps we discussed earlier on. Then step 2. Determine the form of a particular solution yp of x. So this will be, we'll discuss different forms So that's what you have. So we'll describe this one, how we pick different forms with respect to the G function. So that's what we'll call it, determination of the form of yp. So step 3 and the second step, second last step, determine the unknown coefficients in yp by substituting yp of x into the non-homogeneous equation and equating coefficients of like terms. And then the last step, form a general solution with or which is of the form y equals to yh plus yp. That simply means the general solution of the equation will be given by the homogeneous solution plus the particular solution. So then now, remember in step 2, we said we have to determine the form of a particular solution, yp. So let's robustly explain the way we determine the structure or the form of a particular solution. So determination of the form of yp. So if first part, if g of x is a polynomial, then we let yp to be of the form a naught plus a1x plus a2x squared plus a3x power 3 . So we can say if this is a polynomial of degree n, then we are going to assume that the particular solution takes the structure of a general polynomial. So where a naught, a1, a2 up to an are to be determined. So that's the first thing. If the structure of g of x is a polynomial of degree n, then you assume that the particular solution has that structure of any polynomial of degree n. Then case 2, assuming that g of x is a product of a polynomial and exponential, then we let yp to be of the form a naught plus a1x plus a2x squared all the way plus an x power n. Then you multiply each of these terms by the exponent term. So that's the second case, that the structure of G is a polynomial multiplied by the exponential term e raised to power kx. Last case, if, okay, so I may not call it last case, so maybe say part 1. If you see or if g of x has a cosine term, or a sine, or both terms, then let yp be given by a linear combination of that cos term plus another sine term. So a cos of this structure, sine of this structure. So whether there's you only see sine or you only see cosine, but the structure of the yp will be a linear combination of both sine and cosine. And then the other thing, if g of x has a polynomial, so a Pn are main polynomial in n by either a cosine or a sine term, then assume that yp will be given by Pn of x times cos of beta x plus Pn x of sine of beta x. So remember, when I write Pn, all those coefficients are taken care of. And so when we have a combination of this sine, exponential, and polynomial, or product of polynomial, cosine, and exponential, you will still get the linear combination where one part, question, yes? Sine? Come again? Okay, so you are referring to this last. So remember, okay, let me probably write this in expanded form to understand what I mean. So I mean, yp will be of the form a0 plus a1x plus a2x squared plus an x power n times cosine of beta x. But then the way we are writing the this other thing, the coefficients will be different. So b0 plus b1x plus b2x squared plus bn x power n sine of beta x. So remember, once you see a sine or a cosine on the right hand side, whether one sine or one cosine, the final form of the particular solution will be a linear combination of both sine and cosine. Reason as to why that is the case is because in the process of finding those unknown constants in the particular solution, it will involve differentiation. And when you differentiate either post function or a sine function, at the end of the day, you'll always be able, you'll always get an answer in the other form. If it is sine, you'll get a cosine, and if it's cosine and the sine at the same time. So that's why whenever we have either of the two, when you're getting the particular form, both of the sine and cosine are taken into consideration. I don't know whether I've responded to your question. There's someone who had asked before another one asked. Have I responded to your question? The first person, just a minute. Okay, good. So now the next person can ask. Yes. 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 Oh, okay, okay, yes, okay, yeah, that's a mistake. That's a mistake. There's no double cost here, okay? There's no double cost. Thanks for noting that. So this is just one cosine. X. So let me just rewrite it and then so write this. So Pn cosine of beta x, and maybe if we like, we can write this one as Qn of sine beta x. Yeah. All that is now clear. Okay. Is that one, have I responded to your question by correcting that? Good. Yeah. So when you teach science students, you're actually never worried. So people know where they are going. So good. So I want us to do some appetizers before we go to real questions. To say, if I give you particular G, how do you guess, or how what would be the correct form of YP? So appetizers. So give the correct form of YP given the following so A, if my G of X is a function 2x plus 4, what will be the structure of my particular solution? Okay, so you ask yourself, 2x plus 4 is which kind of a polynomial, or which type of function is that? Of degree? Degree of that one, degree 1. So this means that YP should be taking the structure of a general polynomial of degree 1, which we can write as A0 plus A1x. Yeah. And if I have G of X is given by 10, what will be my choice for YP? Just A0. That's a constant, okay? So YP will be simply A0. Please, there's nothing special with writing A0 or A1. You can say C1, C2, or AB. So the thing that there are constants to be found. If we have G of X to be given by x squared. Correct. Yeah. These are very powerful class. I didn't expect that, but that's good. So the key thing is that the function given is a polynomial of degree 2. So when you are writing the yp, you write the whole structure of a second degree polynomial. So you don't just write a2x squared. You write the whole structure, the whole general structure of a degree 2 polynomial. And so you have to find a0, a1, and a2. Good. And if we have g of x be given by e raised power 2x, what will be our yp? Correct. Just a constant times the e power x 2x itself. And if I have g of x given by x power 4 plus 2x plus 9, what will be my yp? Yes, you are free. There's no problem. Okay. Cx to power 4 plus dx power 3 dx to power 2 just f, and then plus. Okay, no. You started well, but you're messing it up. Okay, someone else to pick from where he has left. Fx plus g, correct. Yeah. So that's the structure of that given yp. So the structure of a polynomial of degree 4, we have the constant, this term with x power 1, this term with x power 2, this term with x power 3, this term with x power 4. So you take care of all of them. And if I have g of x is given by sine x, then what will be my yp? Okay, sine x. True. Is that the final answer? Yeah. So a cos x plus b sine x. Then if my g is given by 3 cos 4x, then what will be my yp? Yp. So I have just the same thing, a cos 4x plus b sine 4x. And then h, if g of x is given by x squared e power 4x, what will be yp? A naught plus a1x a2x squared Yeah. So simply know that this is a quadratic term. So there's a general structure of quadratic and multiplied by the exponent. So in similar manner, do get as many examples as you like to see the different structures of yp when you are given g of x, because that's usually the starting point. Now, we are now mature to do an example on how to solve a non-homogeneous equation by method of undetermined coefficients. Yeah, so solve the following non-homogeneous equations. So the first equation is y double prime plus 5y prime plus 6y equals to 2e power t. B, y double prime plus 5y prime plus 6y equals to 2 t squared. Okay, just for consistency, let's just use our variable to be x. So make this x, so 2x squared, and then plus 3x, c, y double prime plus 5y prime plus 6y equals to 3 e raised to power negative 2x, and d, y double prime plus 4y prime plus 6y equals to 4 cosine of x. By the time we solve a up to d, you should be able to be trusted by this method. So when you go through the whole solutions from a to d, you should stand on your own. So copy the questions. And then let me know when you are ready for us to solve the questions. Let me know when you already copy the questions. Okay, good. So now, this being a faculty of science and technology, it picks the best students from the whole country. So I want to trust you with the homogeneous solution for A. So remember, the first step is to get homogeneous solution, i.e. solve y double prime plus 5y prime plus 6y equals to 0. So the homogeneous solution is obtained by fixing the right-hand side to be 0 and then solve the resulting equation. Can you be trusted with that? Good. So please go ahead and tell me what is YH. Solve this differential equation. You are using just the same techniques we are doing last time. Yes? Yes, yeah, that is what will separate boys from men. Yeah. For now you may, actually, because you are a science student and you are very bright, you can actually know the characteristic equation and know the answer. So there's no problem by as at now. But in terms of if you are given this thing in an exam setup. You show everything, don't leave anything to chance. Okay. Yeah. So YH will be C1 e power negative 2x plus C2 e power. Yeah. Is there anyone with a problem on how to get that solution? Probably, maybe that's not a science student. So that is our homogeneous solution. Some people call it complementary solution. So YH is the first step, and we have already gotten the solution. So what follows, if you go to the steps, so this is step 1. Step 2, so get the form of YP, correct. So what is a form of YP? Now remember, the form of YP is determined by the structure of the G of X. So G of X is 2e raised power X. So what would be the correct form? A naught e raised power X. Okay. Yeah. So when we say let this one be the particular solution, and if you remember from the beginning, a solution to a differential equation is a function that satisfies the given differential equation, which means that when we replace the function and its derivatives into the equation, then the equation is satisfied. If all the two sides will give us the same value. So remember, the left-hand side of the equation involves second derivative and first derivative. So what we are going to do is to get the derivatives of this function, replace into the equation, and then solve for the unknown a naught. So if this is the case, yp prime will be given by correct. Remain the same thing. And the second derivative, the same thing. So that's what we have. So we replace this into the differential equation. So which means y double prime plus 5y prime plus 6y, which is the left-hand side of the equation. And saying that yp is a solution means that when we replace into the equation, we get a naught e raised power x plus 5. This first derivative is a naught e raised power x plus 6. The function itself is a naught e raised power x. And since we have already concluded that this is a solution to the equation, it satisfies the equation. So which means what we get after substituting the function and its derivatives on the left-hand side must give us the same value on the right-hand side. So that will equate to 2e raised power x. So a naught e raised power x plus 5 a naught e raised power x plus 6 a naught e raised power x equals to 2 e raised power x. So can you give me the sum on the left-hand side of that equation? What the final sum on the left-hand side is? So I have 12 a naught e power x equals to. So what is a naught? A 6. 1/6, because this means that 12 a naught must be equals to 2. So 1/6. So therefore, yp of x is 1/6 e raised power x. And then the solution, the general solution, y of x is given by the homogeneous solution plus the particular solution, which means we'll have y of x equals to our YH was C1 e power negative 2x plus C2 e power negative 3x, and then plus this YP. So remember, the particular solution doesn't have a constant of an arbitrary constant. That arbitrary constant should be solved in the process of assuming its correct form. So this is where the problem stops, or the final solution to part A. So for part B, we are not going to recalculate the solution to the homogeneous part because it's the same structure. So this, when you equate the right-hand side to 0, you see clearly that the resulting homogeneous equation is exactly the same as the homogeneous equation in case A, so the answer will be the same. So in B, we still have the same YH. So YH of x remains to be C1 e raised power negative 2x plus C2 e raised power negative 3x from A above. But if the equation was, the structure was different from A, then you have to use the same steps to solve the solution for YH. So so what is the G function in this case? Two x squared Okay, so say x squared plus bx plus a, okay? Yeah. So this, remember the G function for this case is 2x squared plus 3x. So which simply means this is a quadratic function or a polynomial of degree 2. So the correct form of the particular solution will be writing the general form of a quadratic expression or general form of a polynomial of degree 2. So this is what we have. Note that even though the g of x doesn't have a constant, but when you want to write the form of yp, when you are writing the expression, it must take all the terms in the standard form. So you don't avoid this a by saying that a was not, there was no constant in the g. So that would be wrong. What guides the structure of the yp is the general structure of the expression g. If it is quadratic, then you give the whole nature of the quadratic function. So we also have two derivatives. So we need to find what is yp prime. To see x plus b and y p double prime to c. So once you have those two values, you replace into the differential equation and equate both left hand side and right hand side. Since from the start you have said that let yp be the particular solution. Question? Oh, ask? Yes. use, yes. So you write ax squared plus ax plus a. That will not be the correct way to do it, because that you are assuming that the coefficient of the term x squared is the same as coefficient of the term x and the coefficient of the constant, which is not necessarily true. If you want to pick that, yes, it will be acceptable if now you give it different subscripts. So we say A2, A1, and A0. Okay, yeah. Or if you want to use the same letter, then you give the subscripts different numbers. It will be okay. So we have y double prime plus 5y prime plus 6y. Now, because we have said yp is a solution, so when I put p here, I put p here, I put p here, I'll get 2c plus 5 into yp prime is 2cx plus b plus 6yp, and yp is cx squared plus bx plus a. Then the whole of this left-hand side from the original equation should give us 2x squared plus 3x. So I will just open this and write like terms together. So I have 2c plus 10cx plus 5b plus 6cx squared plus 6bx plus 6a equals to 2x squared plus 3x. So you can rewrite this as 6c x squared plus 10c plus 6b x plus 2c plus 5b plus 6a equals to 2x squared plus 3x. You don't lose anything by saying plus 0. The reason as to why I'm writing 0 on the right-hand side is to enable me do comparison of the coefficients with a lot of ease, so that constants I put together, coefficient of x on the left-hand side and right-hand side, I equate them. Coefficient of x squared on left and right are also equated. So that will mean that 6c must always give us 2a, just 2. So remember 6c x squared, this is 2x squared. So which means what the x squared on the left-hand side is carrying must be exactly the same value that x squared on right-hand side is carrying for the equality to be true. So 6c must be 2, and then 10c plus 6b must always be 3, and 2c plus 5b plus 6a must always be 0, correct? Yeah. Then you start solving each of those unknowns one by one, and the easiest one to solve in this case is c. So what the value is 1/3. So simply dividing through by 6 in the first expression gives us c to be 1/3. Now with that answer for c, replace in the second equation and get b. So 10 times a third plus 6b equals to 3. So what is the value of b? Correct. Correct answer is -1/18. If you have a different answer from that, it's an answer but a wrong one. So we can get the remaining unknown A. So 2C is a third. B is given by -1/18, and then plus 6A equals to 0. Do the necessary and tell me the value of A. Don't be scared by what you get. A is 108, correct. So these are correct values. So once we have the constants A, B, and C, we replace into our YP to get now the exact particular solution. So therefore, the particular solution YP of X is given by a third X squared minus 1/18 X, and then minus 7/108. So we have done everything. So just to write the final solution. So the general solution is Y of X. You take the homogeneous solution, you add to the particular solution. So which means that the solution will be C1 e raised to power -2x plus C2 e raised to power -3x plus a third t squared minus 1/18 x minus 7/108. Come again? Oh yeah, thanks for noting that. So this will be x squared. I told you that when you are dealing with science students, you are never worried. People will see where the problem is. So this is square. Correct. So that is the solution for that problem in B. So let's see the C. The promise was that by the time we finish all the 4 problems, so you should be able to solve these problems on your own. So C, I hope you agree that the YH is remaining the same thing. Yeah, because it's the structure of the left-hand side of that equation is exactly the same as what we have in B and C, B and A. So here, YH of X is given by C1 e raised to power -2x plus C2 e raised to power -3x. So this is a solution as in A. So we don't have a problem on calculating the homogeneous solution. So next, we calculate, we obtain the form of particular solution, YP. Can you be trusted with that? What will be the YP? So YP is A power -2x. Okay. So let's see. So if that is the YP, then YP prime will be negative 2a e power negative 2x, okay? Which method are you applying to get that derivative? Chain rule, correct. Then yp double prime becomes positive, eh? Yeah. Okay. So I want you to do the remaining part. So do the substitution. Substitute so that you have yp double prime plus 5yp prime plus 6yp. What do you get? Okay, so maybe we can read together 4a e power minus 2x plus 5 into minus 2a e power minus 2x plus 6 into a e power minus 2x. This must be equals to 3e raised power negative 2x. Good. So we'll have 4a e power minus 2x minus 10a e power minus 2x plus 6a e power minus 2x equals to 3 e power minus 2x. So what is the value of a? A is 0. Don't disappoint your high school math teacher. What's the value of a? That equation. 0. You are sure a is 0. You can bet your life on that. That a is 0. What makes it to be undefined? Okay, let's religiously do the next step. So when we add all the terms on the left-hand side, you get? So we have 4a minus 10a plus 6a, then everything is multiplied by e raised power minus 2x equals to 3 e raised power minus 2x. So what's the value in this bracket? 0. So 0 e raised power minus 2x equals to 3 e raised power minus 2x. So 0 times e power minus 2x, 0. So 0 equals to 3 e raised power minus 2x. Can that equation see the doors of heaven? This equation will not be allowed in heaven by St. Peter's. So this is not a true statement. There's no way 0. Okay, so if you divide through by 3, you claim that e power minus 2x equals to 0, which can never be true, even in hell. So mean that there's a problem. Yeah, there must be a problem. And the problem is likely to be from the choice of yp. Okay, y double prime. What's the value of y double prime? Negative 4. No, there's no problem with the derivatives. Yes. Mm. Mm. Okay. So if that's the case, what's your name? What's your name? Pius. Okay, Pius will go to heaven. That's true. So it will always be true that. So remember, there's no mistake. Don't doubt yourself with the what you are giving the steps by us writing this. With all the discussion we did at the start before we started doing the examples on if you are given G, how to pick YP, there is no mistake in having this. It's very, very, very true. But the reason that's why we are landing into problems is because the function G that is on the right hand side of the equation we are solving happens to be one of the solutions for the homogeneous equation. So if what is contained in G is one of the solutions for the homogeneous equation, we'll always land into these troubles. We'll always experience this. If the G function has, or if a G function is one of the terms in the complementary solution, always, however good choice you pick from the discussion, general discussion on the solution of the equation by method of undetermined coefficients, will always land you in problems. So to get the correct choice of YP, you need to ensure that the YP you pick is linearly independent with respect to the solutions, which gives you the complementary solution. So for this case, since there's an e raised power negative 2x in YH, to get the correct form of YP, you are going to multiply this form that you are writing by an x so that it removes, so that we get two solutions which are linearly independent with respect to what is contained in the homogeneous equation. In the same way, we were dealing with problems where we are having repeated dots. So to get two linearly independent solutions, we are multiplying the second part by x. So it's the same thing. So when you multiply yp by x, what you have chosen, you multiply this by x, then it will give you the correct form. So here, the absurdity is caused a raised power minus 2x is in YH. So the correct choice of YP will be given by ax e raised power minus 2x. So which is linearly independent with this function, which is in the YH solution. So with that choice of YP, you should not be in trouble as in the first case. So someone had a question. Or has it been answered? So therefore, we are saying that the correct YP will be ax e raised power minus 2x, which means the YP prime will be -2 So which rule are you using? product tool. So if we let u to be ax, so the derivative of that part is a, and then multiplied by e raised power minus 2x. And then when you differentiate this, you have minus 2ax. Is that correct? Okay. Then y p double prime. Okay, so let's do it step by step. So we have negative 2a e power minus 2x. That will be the derivative of the first term. Okay. And then minus 2a into derivative of x is 1. And then times e raised power minus 2x plus derivative of e raised power minus 2x negative after multiplying by the u function. Yeah. So which will be minus 2a e raised power minus 2x minus 2a e raised power minus 2x, and then plus 4ax e raised power minus 2x. So you said the final answer will be minus 4a e power minus 2x plus 4a x e raised power minus 2x. Confirm that. Yeah. So then now when we substitute into the differential equation, we get minus 4a raised power minus 2x plus 4a x e raised power minus 2x plus 5, and then yp prime is a minus 2x minus 2a x e power minus 2x, then plus 6, yp is ax e raised power minus 2x. So this will give us the final answer on the right hand side is 3 e raised power minus 2x. I trust that you can do the expansion of the brackets on the left hand side and equate like terms. What is the end sum on the left hand side? End sum on the left hand side after opening and collecting like terms. A, correct. Then so this now makes sense. So if that's the case, mean that the value of A is 3. So therefore, yp is given by 3x e power minus 2x. Yeah. So then now we can get the final solution. So the general solution is y of x is yp, okay, yh plus yp so which will be given by y of x is c1 e power minus 2x plus c2 e power minus 3x plus 3x e raised power minus 2x. So remember, if in the same question you have been given either boundary conditions or the initial conditions, you can get the actual values of C1 and C2. Then the last part, D. D, we are also not worried about the YH solution. It will be the same thing because the structure of the homogeneous part is exactly the same as the previous three cases. So YH remains to be C1 e raised power minus 2x plus C2 e raised power minus 3x as in the previous case. So what is the g of x in this case? 4, yes? For which question? Part D. It is the same, it was the same thing. So if we do that, then I change it to the same thing. So the question is, so they're the same. Yeah. So it's just, you see, being math teacher is very nice. You don't have to struggle. So you just use one example and give hard exercises to students to solve. So I didn't want to struggle. So that's why I'm just using the same left-hand side. But what you meet will not necessarily be as obvious as that. So this is just to give you the way, and then you can solve other problems using the same steps. So g of x in this case is 4 cos x. So which means that the correct YP correct. So a naught cosine of x plus a1 sine of x. So since remember we said when the right-hand side involves cosine or involves sine or even combination of both, when you are getting the YP, it should have the cosine part and at the same time sine part. The reason as to why that one is the case is because in the process of carrying out the derivatives, you'll always meet cosine and sine on the way. So YP prime sine x plus product. And then when you get the second derivative, and then product. So that's what we have. Now with those values, we replace into the differential equation. Yes. 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 X squared cos x. That's if that were the g of x. That's a good question. So what's the answer? The class, you have a question. So you see, also the key thing is that you know this is quadratic part. Okay. X squared is quadratic. Do you agree? Yeah. So x squared is a quadratic and these are cost functions. So which means your structure should be of this form. So whereby this will be a naught plus a1x plus a2x squared, then multiplied by cos, and then plus b naught plus b1 plus b2x squared, and then times sine of x. So that's the structure of the YP. So the key thing is that when you see a cos, then sine comes into picture, both sine and cosine. So there are two parts. There's part that involves the cosine, there's part that involves the sine. I remember this constant is different from this other constant. We are using different letters to denote the constants here. And so when what is before the cosine is not a constant term, you are given a polynomial multiplied by cosine. So it will be the same structure. So you will be inputting here polynomial, and you'll also be inputting here polynomial, where the coefficients of this polynomial are different from this coefficient. And then you can move on. Does that answer your question? Good. So now let's do the substitution. Yes. 4 cos squared x. So we are not happy with this. So we are not going to use this method to solve it. So remember, that's why from the start, we started by giving that as a disclaimer, that for this method to work, we need things of this form. That's why we gave this disclaimer. So it is what you're asking is a possibility is true, that the right-hand side can involve a function of that form. So the equation can be solved, but not by this method. Okay. Yeah. So it is a possibility that g of x can take that, but if that's the case, then an determined coefficient method will not apply. So remember, this method only applies their exponents. Then trigonometric must come in this form of cosine of a value times x or times t, sine of a value times x or t, and then the normal exponents, and then the terms of the polynomial. Either it can be in x or it can be in t. But if your function doesn't take one of the structures given here, then this doesn't work. The method doesn't work for that case. Who knows? Maybe the other method will work. But here from the word go, we'll say that when that is the thing we are not happy, this method is not going to help us. So think of a different method. So substitute. So y double prime plus 5y prime plus 6y. So I put p, I put p, I put p. I'll get minus a naught cosine of x minus a1 sine of x plus 5 minus a naught sine x plus a1 cos x, and then plus 6 a naught cosine of x plus a1 sine of x. So it should give us the right hand side is 4 cos x And you don't lose your ink by forcing a term in sign on the right-hand side. So I want you to open brackets and simplify and tell me what will be the coefficient of cosine and sine. Yes, cosine will be. What should I write in the brackets? Negative a naught plus 5a1 plus 6a naught. That end. And then for sine, negative a1. Okay, negative 5a naught plus 6a1. So we can go further and simplify. So the first bracket will be 5a naught plus 5a1. And then the second bracket, negative 5a naught plus 5a1. Good. So we are claiming that the two sides are equal. So if they are equal, then the coefficients of cosine must be the same on either sides. And similarly, coefficients of sines must also agree. So this will mean 5a naught plus 5a1 is 4, quality equation 1, and minus 5a naught plus 5a1 is 0, quality equation 2. Then solve simultaneously. So this is what you did in Form 1. So you have the answer already? So if you change into a fraction, 2/5. And what is a naught? Yeah, they are the same values. So therefore, yp is nothing but 2/5, and then cosine of x plus 2/5 sine of x. So then now the general solution is always y of x is yh plus yp, which will be y c1 e power minus 2x plus c2 e power minus 3x plus 2/5 cos of x plus 2/5 sine of x. Then you get your 4 or 5 marks. So note the way we get the structure of the yp. So the key thing, the structure of getting yp, if the structure of your yp, some of the functions take the same structure as what you have in the homogeneous solution, you need to multiply them by the independent variables. Assuming now, just by the way, if you are assuming there was another question where you solve for yh and you get c1 e power minus 2x plus c2 x e power minus 2x, and g of x is given by x e power minus 2x. What will be the form of the yp? A naught? A naught? X squared? A power minus 2x. Do you agree? That's even me, I don't know. I want you to explain. Mm. Mm. Yes. Mm. 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 Okay, maybe if I may re-ask another question, good for explanation, but even before you check what is on the YH, what does this one tell you? So, I'm saying, forget about the solution of the homogeneous equation. If this is the structure of your G, if this is the G of X, forget about things which are on YH. What should be YP? If we hold our emotions, yeah, because that's a linear, okay? From the word go, this is what you expect to have, okay? From the word go, that is the structure of the YP. If you have not actually even checked what you have on the YH. So if the YH is not having things which are multiples of the x e power minus 2x, then this is what you expect. But now that you are now told that the correct structure of G of YH, or the homogeneous solution, is now this other solution. So what now do you do? We add an x squared, so that now it removes the it introduces now the independence. So remember, yes. Okay, so people are still understanding this. You have already understood this. That point. Okay, good. Okay, good. So then now, I cannot do everything in class. That would not be teaching. So the remaining method, please check out how it works. The method of variation of parameters. Either you can use your library, or you can use your handouts, or you can use the recording that I shared previously. But be assured that